All right, everybody. In last lesson, we learned about resistive circuits, and today we're going to go over two different resistive examples. So let's get right into it. So first of all, we should just take a look at the circuit and figure out what is parallel and what is series, and if there are any ones that are not parallel nor series, or if we can simplify this further. So, first of all, I see this right here, and I see that these guys are in parallel between the two of them. So, the 2 ohms and the 2 ohms are parallel. And as you can see, so we have step 1, and I like to do these in steps just so that I can remember everything that I'm doing. And I'm going to go ahead and draw out each circuit as we go along so that it will be easier for you guys to visualize. Okay, so step 1. So we're going to say 2 and 2 are parallel, and this is the symbol for parallel right here. It's just 2 lines. And we know that they're the same, so we can use our little cheat R over 2. So 2 over 2 equals 1 ohm. And redrawing this circuit, we get this new circuit right here. So what is the next easy thing that we can do? So this guy right here, actually I should do this in red. You can see that this right here is this portion of the circuit that I had condensed. So the next portion that I'm seeing is pretty easy is this right here. So these guys are in parallel. I mean, not in parallel, in series. So we have step 2, and we're just going to do 1 plus 1. So plus is the symbol for series. So 1 plus 1 is just 2 ohms. And once again, going to redraw this circuit. And obviously, when you're doing these problems, you don't have to redraw the circuit every single time. But once again, for the sake of everybody here, I'm going to go ahead and just redraw the circuit every time. But in future videos, when I am solving these problems, I will not be drawing them out every single time because it's inefficient, and hopefully by then you'll understand this concept relatively well. So now we have 1 ohm right here, and once again we can simplify this right here, and so we're going to get step 3, which is 1 and I'm sorry, not 1, 2 and 6 in parallel with each other, and we're going to use our little trick here, 2 times 6 over 2 plus 6, which is equal to 1.5 ohms, and that is the last, and so we get our next circuit of this right here, and as you can see, the very last simplification is just a series of all of these guys. So ultimately in this problem, I actually did not say what, solve for R equivalent as seen by the 12-volt battery. And so what the 12-volt battery will be seeing is 2 plus 1 plus 1.5 plus 4, which is equal to 8.5 ohms. So the very, very, very last circuit, all of that just condenses down to this guy right here with an 8.5 ohm resistor and a 12-volt battery. So what does this mean? That means this circuit right here can be represented in this circuit right here. And to find the current, all you have to do is do Ohm's law, and you have the equivalent here and you have the total voltage, and so you can just get the current from there. So that's how you do one of these resistive examples. The next example we're going to do may seem a little more complicated, and I'm gonna see if I am not lazy enough to write down this whole thing. But essentially what you're going to do is you're going to take all these series guys, and then once these guys are condensed to one resistor, you're going to add them up. You're going to perform the parallel simplification. So let's go ahead and do that. And I think what I'm going to do is, instead of drawing the entire circuit, I'm only going to draw the right and left portions solved individually, because you'll see that these two sides can be treated as independent, and then from there they will be parallel to each other once we've simplified them all completely down. So we're going to solve the right side first, and so we've got the 5 plus 5, so right here is going to be 10 ohms. Right here is 15, and then we're going to parallel these guys, and so step 2 is 15 and 10 in parallel, which is 6 ohms. Okay, so I think what I'm going to do actually is speed up the video and show you guys the algorithm I have, and then once we have this simplified, I'll start talking again. Okay, so we found out that this side simplifies down to 22.5 ohms. So this side of the excuse me, the what volt battery? We actually don't have a voltage for this battery. So this arbitrary voltage battery is 22.5. Oh, sorry. It's not arbitrary. I didn't see that 2 volts. This 2 volt battery right here. So this guy simplifies into this circuit right here. Now we have to do the left side. So step 3, I'm just going to call it step 3, is simplify the left side. And I think from seeing that algorithm there, you can just do all of this in your head or on the calculator, but we know that 10 plus 3, sorry, I'm getting ahead of myself. 7 plus 3 is 10, and 10 is parallel with 30, so that is equal to 10 times 30 over 40 because of 10 plus 30, and we get 7.5. And this, so this all right here is 7.5 plus 10, so we get 10 plus 7.5 is equal to 17.5 ohms. So our circuit reduces down to... Now you may be wondering, what do we do here? Well, let's see. Notice how this is all one node, and this is all one node, and these resistors are connected in together by these nodes. So therefore, all of this is parallel. So if you really wanted to, if this messes with your brain, because it did with mine, and it confused me and a few other classmates, but if it messes with your brain, you can rewrite the circuit to be like this. It's all the same. This 2 volt battery sees this circuit the same way as this. So all you have to do is 17.5 paralleled with 22.5, which equals to 17.5 times 22.5 divided by 17.5 plus 22.5, which is approximately 9.843 ohms. And that is the R equivalent as seen by this 2 volt power source. And that's it.